Next is a comparison of valence bond and molecular orbital theory. Okay. Next is comparison of valence bond theory and molecular orbital theories. Comparison of VBT and MOT. Okay. Similarities, common characteristics of VBT and MOT are similarly similarities, that means common characteristics. Common characteristics. Common characteristics of valence bond theory and molecular orbital theory. Okay. First point, according to both the theories, the basic principle involved in the distribution of electrons are similar. Hence, in each orbital, atomic orbitals and molecular orbital, maximum 2 electrons are present. Okay. In each orbitals, atomic orbitals are molecular orbitals. Maximum 2 electrons are present. Maximum 2 electrons are present. Maximum 2 electrons are present. Okay. Second point. Both explain covalency and formation of sigma and pi bonds. Both explain covalency and formation of sigma and pi bonds. Third point. The electron density is maximum between the nuclei. The electron density is maximum. The electron density is maximum between the nuclei. Okay. Fourth point. Third point, the electron density is maximum between the nuclei. Fourth point, the atomic and molecular orbitals are filled up according to above principles. Both the atomic and molecular orbitals are filled up according to principles. Okay. Pauli's exclusion principle and Hund's rule. Okay. Fifth point, similarities. Both explain the directional nature of covalent bonds. Both explain the directional nature of a covalent bond. Sixth point, the symmetry of overlapping overlapping orbital remains the same, remains the same and has approximately same energy. Okay. Seventh point. Both explain the non-existence of helium molecules. Both explain the non-existence of helium molecules. Okay. There are 7 points for similarity or common characteristics of valence bond theory and molecular orbital theories. Okay. First point, comparison of valence bond theory and molecular orbital theories. Similarities, common characteristics of valence bond theory and molecular orbital theory. First point, according to both the theories, the basic principles involved in the distribution of electrons are similar. Hence, in each orbitals, atomic orbitals or molecular orbitals, maximum 2 electrons are present. Second point, both explain covalency and formation of sigma and pi bonds. Third point, the electron density is maximum between the nuclei. Fourth point, the atomic and molecular orbitals are filled up according to a Pauli principle, Pauli exclusion principle, and Ohm's rule. Both explain the directional nature of covalent bond. The symmetry of overlapping orbital remains the same and has approximately same energy. Both explain the non-existence of helium molecules. Okay. Difference between valence bond theory and molecular orbital theory. Next is difference. We study about the comparison of VBT and MOT. First is similarity, and next we will be study about difference between valence bond theory and molecular orbital theory. Difference between valence bond theory and molecular orbital theory. Okay. First number VBT and in this MOT. Okay. Valence bond theory and molecular orbital theory. First point. The atoms participating in covalent bond do not lose their individual identities. In valence bond theory, the two atoms participating in covalent bond do not lose their individual identities. In here, in MOT, the two atoms participating in covalent bond lose their individual identities. Okay. Second point. Atomic orbitals are monocentric. atomic orbitals are monocentric is that an electron moves in the field of one nucleus only. In molecular orbitals are polycentric are polycentric is that an electron moves in the an electron moves in the field of more than one nucleus. Okay. Third point. Resonance is an integral part of valence bond theory. Resonance is an integral part of VBT, valence bond theory. Okay. And resonance has no role in MOT. Resonance has no role in molecular orbital theory. It explains paramagnetism of oxygen molecules. Okay, oxygen molecules. Fourth point. It does not explain paramagnetic of oxygen molecules. Valence bond theory does not explain paramagnetism of oxygen molecules. MOT accepts molecular orbitals theory accepts the ionic structures like A plus, B minus and A minus, B plus in a molecule like AB. In a molecule like AB. Okay. Explain VBT, valence bond theory, rejects the ionic structures. Rejects the ionic structure A plus, B minus and A minus, B plus in a molecule like AB. Okay. Difference between valence bond theory and molecular orbital theory. VBT, the Two atoms participating in covalent bond do not lose their individual identities. But in molecular orbital theory, two atoms participating in covalent bond, their individual identities. Second point, atomic orbitals are monocentric and an electron moves in the field of one nucleus only. But molecular orbital theory are polycentric and an electron moves in the field of more than one nucleus. Third point, resonance is in an integral part of valence bond theory, but resonance has no role in molecular orbital theory. It is explain paramagnetism of oxygen molecules. Fourth point, it does not explain paramagnetism of oxygen molecules. Okay, but it explain paramagnetic of oxygen molecules. According to molecules orbital theory, this is explain the paramagnetism of oxygen molecules, but VBT theory does not explain the paramagnetism of oxygen molecules. Okay. Last point, valence bond theory rejects the ionic structure like A plus B minus and A minus B plus in molecules like AB. But molecular orbital theory accepts the ionic structure like A plus B minus and A minus B plus in molecules like AB. Okay. And next point is sixth point, valence bond theory is simple to apply, but molecular orbital theory is difficult to apply. Okay. And seventh point, molecular orbitals are formed by approximation method. Molecular orbitals are formed by approximation method LCAO, but atomic orbitals are formed by the combination of the space functioning of two unpaired electrons. Okay. Electron deficient compound. Next is electron deficient compound. Electron deficient compounds. Next study, electron deficient compound. Electron deficient compound. Okay. The electron deficient compound are those which have insufficient number of electrons, insufficient number of electrons then the number of two electrons bonds, then the number of two electrons bond. Okay, then the number of two electrons bonds are the compound in which there are not enough electrons to form two electron bonds between the atoms are called electrodeficient compounds. Okay, are the compound in which there are not enough electrons to form two electron bonds to form two electron bonds between the atoms are called electron deficient compound. Electron deficient compound. Example BH3 whole twice BeCl CH3 whole twice N, and Al CH3 whole thrice N. ETC are electron deficient compound as they do not consist enough electron to form two electrons bond between the atoms. Electron deficient compound are given more by the element of 13 group, okay, than those of any other group. This is because the atoms is 13 group have the tendency to be 4 covalent but have only 3 valence electron, NH2 and P1, B2H6. B2H6 is an example of electron deficient compound. The structure is given as boron, boron, 1 hydrogen, 2 hydrogen, that is 3 hydrogen, 3 hydrogen, that is 4 hydrogen, 4 hydrogen, that is 5 hydrogen, and that is 6 hydrogen, okay. Number of bonds in B2H6 equal to 8. B2H6 equal to 8. Electrons needed equal to 2 multiply 8 equal to 16. 2 electron per each bond. That is 2 electron per each bond. 2 electron per each bond, okay. 2 electron per each bond. As boron has 3 bold electron and valence electron, and hydrogen has 1 valence electrons. Boron has 3 valence electron and hydrogen has 1 valence electron, okay. Total valence electron in B2H6, total valence electron in B2H6, total valence electron in B2H6 is 2 multiply 3 plus 6 multiply 1 equal to 12, okay, equal to 12, because 3 valence electrons and 1 valence electrons, that is 6, and 2 multiply 3 plus 6 multiply 1 equal to 12. Thus there are 12 valence electrons sufficient to form 6 bonds, but B2H6 has 8 bonds. As shown in the above structure, as a matter of fact, that is boron, hydrogen, B has 2 electrons, 3 centric, B has 2 electrons, 3 centric bond, and there is 1 electron bond for boron, 1 electron, hydrogen, 1 electron, boron, okay. Multi-center bonding in electron deficient molecules. Next is a multi-center bonding in electron deficient molecules.